So just a quick review for geometry. What we learned on the last video you watched, which was Thursday night and Friday in class, you will have noticed that an inscribed angle is equal to 1/2 the intercepted arc. What that means is if you have a circle and then you have an inscribed angle, then you can find the measure of the angle. It'll be 1/2 the measure of this arc, the intercepted arc. Number two, the second thing we learned is if two inscribed angles intercept the same arc or congruent arcs, then the angles are congruent. So what happens here is this sort of picture. Here's an inscribed angle, and then here's an inscribed angle, and you'll notice they intercept the same arc. So therefore those angles are going to be congruent, exactly the same size. So those are the two facts you need to know as we move forward, and that will help us to do a few other kinds of problems. Next slide, I'm going to talk to you about the new theorems. So the first theorem occurs when you have a diameter, and in our circle here, AC is a diameter and the circle is circle P. And then what happens is if you have an inscribed angle where it's inscribed and the 2 points that it intersects the circle are endpoints of a diameter, then that means the inscribed angle is always a right angle. And that's a nice feature. If we have a right angle, then this side here is always a diameter. If this is a diameter, then this is always a right angle. So why is that true? Well, it is true because a diameter cuts a circle into a semicircle, and therefore we know that the arc is going to be 180 degrees in a semicircle, and therefore we know that that angle has to be a right angle, and because it's going to be 90 degrees. If the angle's 90 degrees, then we know the arc is twice as big, or 180 degrees. And so that's the first theorem. You can see this on page 711 in the textbook at the bottom, if you want to copy it when you get to school. So the next theorem is about quadrilaterals being inscribed in a circle. And when I say the word inscribed for a shape in a circle, I mean that the vertices, all the points that you make the polygon with, are on the circle. So what happens in this case? Well, the theorem says if the quadrilateral is inscribed in the circle, then the opposite angles are supplementary. So what the theorem says is angle A and angle C are supplementary, and angle B and angle D are supplementary. So why can you say that? Well, the reason why you can say that, let's look at angle A and angle C. We know that the whole circle is 360 degrees, but angle A is, if I draw this line, is this part of the circle, and angle C is this part of the circle, and the blue and the red arc add up to 360, but each of these arcs are half of each of those arcs. So their sum has to be 1/2 of 360, which is 180, and therefore the angles are supplementary, because if you remember from the first month of school, supplementary angles are two angles that add up to 180. So right angles are inscribed in semicircles, and if you have a quadrilateral, the opposite angles are supplementary. That's the two theorems. The next slide is going to give you a couple of problems where you can practice this idea. So here's two application problems of the problems we want to do. Let's look up above at the black diagram first of all. Make sure you pause the video and copy it, and then you can come back and try the problem and then see how you do. So this first problem we want to solve for x first of all. And our challenge in solving for x is we need to figure out the relationship between angles C and E. Well, as you can see, CE is a diameter because of this little dot right here. We can see that. And so, therefore, since it's a diameter, that means angle D is a right angle because it's inscribed in a semicircle. Well, since it's inscribed in a semicircle, we can go ahead and we know that all three of these angles are going to add up to 180, or we know angle C and E will add up to 90. And so we can find x in either manner. So I'm going to find it by doing 3x plus 5x plus 12 plus 90 equals 180. And solving that problem, I'll solve the rest of it over here. I get 8x plus 102 equals 180. And therefore that's 8x equals 78. And so x equals 78 over 8. Which is 39 over 4. So to find the measure of angle C, we want to then do that. We just need to plug in 5x plus 12, and we know x is 39 over 4, so we can solve for C by taking 5 times 39 over 4 plus 12, and this is going to be a bit of a booger because you have to do fraction work, but that's not too difficult. So 5 times 39 is 150, and 45, it's 195 over 4, and 12 with a common denominator is 48 over 4. And so the measure of angle C is equal to 235 plus 8, 243 over 4 degrees. But we don't like that as an answer, so we go ahead and divide it out, and we get 60.75 degrees. And that's the solution for the measure of angle C. So to do this problem, we have to use the quadrilateral theorem that opposite angles are supplementary. So let's find angle S right here. Angle S doesn't have anything in it, but what we know is it's supplementary with angle W, its opposite angle. So the measure of angle S plus 45 degrees is equal to 180. And if we subtract 45 from both sides, then we end up with the measure of angle S is equal to 135 degrees. So the next problem, last problem is measure of angle R and measure of angle T are supplementary, so we can add the plus the measure of angle R, and that's going to equal 180 degrees. And so the measure of angle T is 2x plus 30. The measure of angle R is 4x, and that's going to equal 180 since they are supplementary. Well, that's pretty simple. That gives us 6x plus 30 equals 180. And 6x equals 150, and if we divide by 6 we get x equals 25, And so therefore, to solve for the angle, all you have to do is substitute x equals 25 into 2x plus 30. So you get 2 times 25 plus 30, which is 50 plus 30, or 80 degrees, for the measure of angle T. So there's our two problems, and that's typical of what you're going to have to do on the rest of this assignment. So for the quiz for today, you just have to tell me the measure of angle T equals 80 degrees. So if you remember that, that would be wonderful. Alright, we'll talk to you in class after you watch this tomorrow. Bye.